Okay, so let me call this as A1, this is A2. This is a 2 cross 2 matrix. Okay. What do I do? Suppose I do Gram-Schmidt's. What happens to this? What is the first step? What is the first step? I take A1, normalize it by A1, right? So that's what I'll do, right? What is A2? I will subtract and then normalize, right? So whenever I normalize, I'll get a number, right? That's all it happens, right? So let me write this. Okay, so A1 by norm of A1. The other one would be A2 minus A1 by norm of A1 divided by norm of A2 minus A1 by norm of A1, right? So this is what I get. Do you agree? This is the vector, right? Okay. So now what transformation led to this, or can we go back and forth, right? So now this is a normal vector. If I want to get back the original, what should I do? What should I do if I want to get back the original? So now, how do you get A1 from this? All that I have to do is scale it with the norm of A1, right? Somehow, right? Then I get A1, right? How do I get A2? A2 is not so straightforward, right? So how do you get A2 from this? First of all, I have to add A1 by something, right? So if you look at this term here, what is this? This is basically some linear combination of A1 and A2, right? Do you agree with this? This is combination of A1 only, right? The second column is a linear combination of A1 and A2, okay? So instead of bothering about what are those coefficients, what I will do is I will write this like this, okay? The first column is alpha A1, okay? Alpha is 1 by norm of A1, right? What is the second column? Let's say if you go back, this is some complicated constant times A1, some other constant times A2, right? So I'll call this as some alpha, okay, beta A1 plus gamma or nu A2, right? This is what you have, right? So this gave me orthonormal vectors. These are our orthonormal vectors, right? Do you agree? So what is this, by the way? Can I write this as a product of two matrix? What should I do? The first column, this is, how do I get this? So if I have a matrix A1, A2, how do I get this? This is the first column, right, of this. How do I get this? I have to select this column, but with the multiplication of alpha. So this is how I do, right? You agree? So if you multiply, it will only select the first column, right? Do you agree with this? Well, actually, I don't need to do this. So if I multiply by this vector, I get the first column of this. How do I get? So this is given by this. What about this? What should I do? What should I do? Again, I'll write it as A1, A2. So what should I multiply so that I get this? So I should select A1, right? But I should multiply it by beta, right? And I should select A2 but multiply by nu, right? So this will. So overall, how do I write this? A1, A2, right? Times what? Alpha, beta, nu, 0, right? Do you agree with this? Yes or no? Huh? Do you agree with this? Right? If I multiply this matrix by the first column, I'll get the first column here. If I multiply with the second column, I'll get the second column here. Right? Do you agree with this? Okay. So essentially, I have written, so this is not my intention, so I have to write it in a slightly different fashion. But nevertheless, okay, so now what kind of matrix is this? What is this matrix called? See, there is a 0 here. What is this matrix called? Upper triangular matrix, right? Now, what is the inverse of an upper triangular matrix? Huh? What is the inverse of this? Let's see. What is the inverse? Can you compute and tell me? Simple 0, alpha, beta, nu. Okay. Simple matrix like this. What is the inverse? I haven't taught you what inverse in this class is, but you would know what the inverse of a matrix is, right? Adjoint of A or determinant of A and all that. Can you try? Hmm? What will happen? See, if you look at this, right, I should remove this, you will get new. So some number. If I do this, I remove this and this, I'll get 0. So 0 will go here. And similarly, I do this, beta will come here and new. So it's an, what do you get? It's an upper triangular matrix, right? Do you agree? Huh? Do you agree with this? Right? So that means this is A, this is upper triangular matrix. Will it get lower triangular? Yeah, you'll get lower triangular matrix, right? Sorry. So now this I will call it as Q. Okay. Okay. So what should I do? Now let me write this. Q is A times U. Right? This is what you get. So what I'm going to do is I'm going to multiply by U inverse on both sides. What do you get? This will be A, right? So A will be Q U inverse. What is U inverse? Lower triangular matrix, right? Right? Or I'll write this as Q times R. Okay. So this is called QR decomposition. So what is so special about this? Let's look at what A is. Okay. What is A? The first column is U1, second column is U2, right? So let's look at that. So A, if you look at Q, for example, the first column is U1, second column is U2. What can you say about U1 transpose U2 or U2 transpose U1? What can you say? How did you get U1, U2? Gram-Schmidt's orthogonalization, right? So what is this? 0, right? What can you say about norm of U1? Which is 1. It's orthonormal, right? So now if I take Q, right? Well, if I take Q, right? Or I'll take Q transpose Q. What do you get? Q transpose is what? U1 transpose this way, right? U2 transpose this way times U1, U2, right? This is what we get. So what is U1 transpose U1? 1. What is U1 transpose U2? 0. What is U2 transpose U1? 0. What is U2 transpose U2? 1. You get identity, right? So Q transpose Q is identity matrix. Okay, is that fine? Okay. So now, so in other words, I can take any matrix for that matter and write it as product of QR using Gram-Schmidt's, right? I won't try to prove the general problem wherein A is any n cross n matrix. The procedure is exactly similar, right? You keep on doing the Gram-Schmidt's and I can write that as a product. Okay, so now I have Q transpose Q is identity. So suppose I have let's say How do I write this? So let me see if I can convince you or use usefulness of this. So what is A? I can write it as Q or X equal to B, right? Now I can multiply by Q transpose on the left hand side. See, matrix multiplication is easy, inversion is difficult, okay? It's a complex operation. So this implies Q transpose Q or X is Q transpose B. Very easy operation, right? So Q transpose B is just a multiplication of a matrix by a vector B. So let me call this as B tilde, right? Now this is B tilde, right? What can you say about Q transpose Q? Identity, right? What do we have? Rx is equal to B tilde. So how does Rx look like? R looks like. So what is this? U is upper triangular. U inverse is lower triangular, right? That means it's lower triangular like this, right? You have entries here and 0 here, right? Times x, x1, x2, xn, which is b1 tilde, b2 tilde, and so on, bn tilde, right? So now, when you multiply, what do you get? The first element multiplied by x, this one, what do you get? This, no, there is R11, okay? So there is a number here, okay? So it's not 0. Everything to the right of it is 0. So R11 times x1 is b1 tilde. So x1 is trivial, right? So b1 tilde divided by R11. What happens to the second one? We saw this, right? So there are two terms here, right? So the first term is what? R21 times x1 plus R22 times x2 is b2 tilde, right? Is that fine? Is that clear? It's fine, right? So keep doing that. So you have, so wait, did I? So I got x1. Now this times x1 plus this times x2 is equal to b2 tilde, but I know x1, so I can compute x2. Easy, right? So, and so on. I won't fill this gap. So it means you need not invert a matrix, right? All that you have to do is do QR decomposition. How do you do QR decomposition? You do Gram-Schmidt's orthogonalization. How do you do Gram-Schmidt's orthogonalization? No inverse, nothing, right? It's like computing the product, sum, squared, square root, and so on, right? So it's a relatively easy way of finding the solution to a set of linear equations, right? This is one way. This is called QR decomposition. Okay, keep that in mind. Is that fine? Any questions? This is the first decomposition that we looked at. You have a class after this? Is Professor whose class is next? Huh? Philosophy. Is he there? Not yet? Okay. So anyway, I'll stop here. So take home lesson for today is Gram-Schmidt's and QR decomposition. Okay, so Gram-Schmidt's, you go through the notes. QR decomposition, you just Google. There are so many entries, and you can see the relationship between Gram-Schmidt's and QR. Okay, I'll stop here. Thank you.